back in the Azure Data Studio, and I created a script that looks pretty daunting, but it's not so bad. There is a use statement that points it to the database I want to use. I'm using the test DB. This script has a little more to it than you've seen so far, and I'll try to go through it and explain it. We declare a SQL variable of type nvarchar max, which is a Unicode max. So this could hold a lot of text. It could be, I think it's up to 2 gigs or something like that. But that's how you can declare a variable that's going to hold the query that actually going to populate the R script, meaning you're going to pass data from SQL Server into the R script and manipulate that data in R and produce some kind of output, and then return it back to SQL Server. Then again, we'll display it into columns and rows. So I'm setting up this variable called SQL, and this is my query. And what it's going to do is going to grab the date and the ticker symbol and this adjusted price from the table stocks that we've been looking at. And I'm filtering only by these ticker symbols. So there's only 3 of them, the S&P 500, AbbVie, and Abbott Labs. And then I'm ordering by ticker, date, in ascending order. And then I create another R script variable of nvarchar max size. And that's going to hold all of the text that will become the R script I'm going to be running. Here I'm only setting reference to this Tidyquant library. Another thing that I'm doing here that you haven't seen before is that I'm actually passing in input data, okay? And the input data I'm passing in is this SQL query, which is sitting in this variable. And it will go in to this data frame, but I also want to give it its own name. I don't want to just use these generic names. So I'm setting this input data _1 name equal to SQL data. And in my R script, I'm referring to the SQL data here, and I'm passing that into this variable in R called data. So this data frame goes into this data variable. Another thing I'm doing in here is that I'm setting the output data name equal to out data instead of that generic one I've been using before. So now this data frame that's going to come out from R is called out data. So it loads it into this data frame, and it uses this Tidyquant, the tidyverse standardization now of piping the data in through from one object to the next. So I'm creating a variable RA that's going to be whatever the result of this pipe flow, this workflow, whatever the result of that is going to go and be loaded into this RA variable. So I'm taking the data frame that came from SQL Server, and I'm piping it by using these 2 and a percentage greater than and percentage. They will pipe it to the next execution layer. And we're using this tidyverse stuff. So I'm filtering the data by where the ticker is equal to, where it's not equal to GSPC. So in other words, only AbbVie and Abbott is what I'm loading into this RA. And then I'm grouping it by the ticker. So partition by the ticker symbol for AbbVie and AbbVie data. And then I pipe that to this function called TQ transmute. And this one will take the adjusted price, and it will create this period return. And the returns that I want to create is daily. And the column name I want to output it to is this RA. So I'm basically inside here now, I'm creating daily returns for the AbbVie and Abbott tickers. So that's what this is doing. It's creating a new column called RA and puts it into this variable. So that's what this part is doing. So we looked at that transmute, the transmute function. this one, you can always go into RStudio and you can look at this function by putting question mark or help in front of it here and hit Control Enter, and it will load it up in this sidebar here so you can read up on what you can do with this function. So down typically towards the end of these, there's some examples you can look at to get a better idea. I don't always think that the documentation in these is very helpful. I usually Google that to find more information about it myself, but you can do that to take a closer look at this. By the way, we also had these the TQ get that we did to get the prices. What you can do is you can run this TQ get options, and here you can see some of the things you can get. Here, the stock price is what we were getting before, but you can also get splits, you got financial, metal prices, there's dividends, there is exchange rates, economic data, key ratios, and so forth. Or you can get data from Google if you prefer not to get it from Yahoo Finance. So that's some you can do. And there's also this TQ index option, and that tells you can get data for individual stocks within these indexes. So you can see the S&P 500 is one, the Dow is one, and so forth. So those are also available within this Tidyquant package. Okay, so go back to the Azure Data Studio, and we ran this for the RA, which is Abbott and AbbVie stocks. We created daily returns inside here. So in other words, I didn't bring them back. I only brought the price back so I can compute the returns here. And so that's the opposite that we did before with SQL Server, where I computed in SQL Server. Now I can do the same thing for the S&P 500, identical, except for this time I want to make it equal to this ticker symbol, only to filter the data that belongs to S&P 500, calculate the daily return again, and then I want to merge the two by using a tidier. It's a dplyr kind of a join function in R that does similar like a join in SQL is, where I'm joining this Abbott data frame with the S&P 500 data frame, and I'm doing it by date. So I'm joining by date. And once I've done that, I can calculate this CAPM from Performance Analytics. And the way that works is you take this data frame you just created and you pipe it to this TQ performance function in the Tidyquant package. There's one for index and one for the portfolio. So for the portfolio is the Abbott AbbVie combination, and for the index it's the S&P 500. And you set up this performance function to be equal to this, and that was coming from the table CAPM here. So you might recall we just looked at that. And then there is also all of these sitting in a row here. I'm going to make into column names in SQL Server. So that's what I'm doing down here. I'm setting with result sets, and then I'm creating a column name for each one of those. And the symbol I'm leaving at that Unicode varchar 50, and the rest of them make into float variables. And I'm set it equal to this with result set. So I can run this now, and it's going to spin for a little bit. And when it's done, you're going to get this result set out. And here you see the column headers with all the calculations that came from the performance analytic package. In RStudio, and question mark TQ performance, and you end up here, you can see that the arguments you're passing in is the data, and this RA is the column of asset returns, and the RB is the column of baseline returns. Actually make it into a stored procedure. So in order to do that, I created the stored procedure get PA CAPM, and I can get to that by opening up my connection here and drilling into my testDB, programmability, stored procedures, the first one here. So I can right click and say, in this case, I'm just going to script it as create. and it brings out the actual code that goes into that stored procedure. So as you can see, this is the name of the stored procedure. Here is all the code that we just looked at. It's just put into a stored procedure format now, and it's returning the result set. So you can easily execute this stored procedure and get the result sets back. Script it as an execute, and it gives me this. And then I can actually run this, and it goes out there and it generates the data, and it comes back like we saw before. Here is the table. So probably a better way of doing this is to create a bunch of stored procedures.